In this video, I want to show you how you can quickly remember the Taylor series expansion of function of two variables without necessarily having to cram the formula. But this thing is going to be building on your knowledge of binomial expansion. So in case you have forgotten binomial expansion, I'm going to quickly revise that with you in a few minutes before we go into the Taylor series itself. Now, for your binomial expansion, you know that whenever you have the simplest power there is a plus b raised to power 2, and that is very, very easy to compute. That's just going to be a squared plus 2ab, then plus b raised to power 2. When you have to the third power, you have a plus b raised to power 3, then that will be a to the power of 3 plus 3a squared multiplied by b plus 3a multiplied by b squared and plus b raised to the power of 3. By the way, if you struggle with binomial expansion, I believe if you're doing Taylor series expansion for function of two variables, you should know what binomial expansion is. So in case you want me to make a special video on teaching binomial expansion, then you can let me know in the comments. So I'm going to be stopping at just power 4, a plus b raised to power 4, that is a raised to power 4 plus 4a raised to power 3b plus 6a squared b squared plus 4a b raised to power 3, then finally b raised to power 4. Now let's go into the Taylor's expansion, and I'm going to show you how this applies. Let's say we want to expand this. Let's say we want to expand this at the point a comma b. Those are the points that we want to use. Now, to get the Taylor's expansion, the first term in the expansion always appears this way. You have f of x comma y will be f of a comma b. So the first term is always the term without any derivative. You have not differentiated anything yet. You're just evaluating the function at the point that you were given. Now, the next thing that follows is you're going to start differentiating it, and it goes like that from the first derivative to the second derivative to the third derivative to the fourth derivative, depending on how far your instructor wants you to go. So let's start with the first derivative. What first derivative means is that you're going to be differentiating, you're going to be finding all the first derivative possible for this guy. And then there are only two first derivatives possible. It is either you differentiate with respect to x or you differentiate with respect to y. Those are the possible first derivative that you can have. But take note, for every derivative that you carry out, you must multiply with the length. For instance, if you are finding the derivative with respect to x, you must find the distance between x and a. And if you are doing derivative with respect to y, you must find the distance between y and b. And the distance between x and a is simply x minus a. And that between y and b is simply y minus b. You must multiply with it and to the magnitude of the number of times that you found the derivative. Let me show you what I'm talking about. So for instance, you want to find derivative of f of x with respect to x. That implies that there must be x minus a involved. Then you find the partial derivative of f with respect to x. But you're not done with the first derivative. You have to do for the first derivative with respect to y as well. So this is going to be, first of all, y minus b. Then you're going to have partial f, partial y. Now, with this, we're done with the first derivative. But this is not where the challenge is actually. The challenge always comes from when you get to the second derivative. Now, when you get to the second derivative, one of the things that we introduce is the factorial. You are doing the second derivative. So you're going to have a 1 over 2 factorial outside because you are on the second derivative. When you get to the third derivative, it's going to be 1 over 3 factorial, and it goes on and on like that. Now, the first thing you do is that you can create a parenthesis here. We are on the second derivative, so the binomial expansion that is going to be useful to us is going to be this one of the second power. We're just going to follow the pattern that this follows. The first thing we have here is a squared. Let that a represent the x side, and let b represent the y side. So it means that this first second derivative I'm going to get will be me differentiating with respect to x 2 times. And that implies that my x minus a will be raised to power 2. And what we follow is the partial derivative of f with respect to x 2 times. Don't forget, all these derivatives, we are going to be evaluating them at point a comma b. I'm going to put that later. I just want to get the expansion cleared. out of the way. Then it follows by plus. There is a 2 here, so there's going to be a 2. And then we're going to be finding the partial derivative with respect to a and with respect to b. Now, this is going to be, first of all, x minus a. Then you have y minus b. So I got that from here. I got that right from here. 2, then x minus a, y minus b. So meaning that I'm differentiating with respect to x and with respect to y. And since the Taylor's series expansion is always for continuous functions, then I don't need to worry about the order of derivative. I can do for x first, then do for y, or do the other way around. I'm still going to get the same result. So this is going to be partial derivative of f with respect to x with respect to y. Now this means that you're doing y first before you're doing x anyways, but it doesn't really matter. Then finally, you can see here we have b squared. So we're doing for y 2 times. So that's going to be y minus b raised to power 2, then the second partial derivative of f with respect to y. And with this, you have gotten for the second term. Let's quickly see for the third term. Let's see what that would look like. Now, for the third term, you're going to have plus 1 over 3 factorial. Now, when you get to the third factorial, so that implies that you're going to be using this part of the binomial expansion. So the first thing is going to be x minus a raised to the power of 3 according to this first term here. And you're going to be differentiating f 3 times with respect to x 3 times plus, following by, you have 3, so that will be 3. Then a squared, that will be x minus a squared. Then b, so you have just y minus b. Now you write the derivative, so you have partial derivative of f with respect to x twice. So you can just write this and you write this instead. And so let's go to the next one. You have 3 again. This time around you have just ordinary a, so that will be x minus a, and that is b squared, so that will be y minus b squared. So what you're going to have is partial derivative of f, of course the third partial derivative, with respect to x and with respect to y twice. But we're not done. So to the last one, we're going to have partial derivative. No, that's not going to be the first thing. It's going to be y minus b raised to the power of 3. Then you have the partial derivative of f with respect to y 3 times. So this is the pattern that you follow. Even when you get to the fourth term, you're just going to be following the binomial expansion. This is going to be guiding you as to know what you're going to need to get. By the way, like I mentioned earlier, all of these partial derivatives, we are evaluating them at the point a, b. We are evaluating them at the point a, b. So take note that for every partial derivative that we have here, they will be evaluated at the point a, b. So I just wanted to show you how to get the expansion without necessarily cramming the formula. If you want to see more videos like this, treating some advanced stuff, then you need to follow me and you need to subscribe to my channel as well. I'll be waiting in the comment section if you need any further help or any specific topic that you would like me to teach. I'll see you in the next one.